So we're going to use these properties then to solve these equations. So to solve for x and y, we need to first eliminate one of the variables. And so that we have a one variable situation, we can solve for that one variable, and then we are going to back substitute to solve for the other. So here, I'm going to combine these two equations together, because if I combine plus 8y minus 8y, what will end up happening is I eliminate the y from the equation. So I'm going to label that equation 1. This is equation 2. I'm going to add equation 2. So when I add those two equations together, I get 5x. The y's cancel out, equals 15. So I solve for x, divide by 5, x equals 3. Okay. So remember that this is a system that we have to, the solution is two-dimensional, or x and y, so we have to actually solve for y as well. To solve for y, what I do is I substitute back into one of the equations. Okay, now it doesn't really matter if I substitute it into 1 or 2. I'm going to substitute it back into equation 2. And when I do that, I now have an equation with one variable, y this time, and I can solve for y. So I get negative 8y. I'm going to add subtract 6 from both sides. Divide by negative 8. I end up with positive 3 over 2. Okay, so those are my two solutions. Well, x equals 3, y equals 1.5. So I'm just going to double check this. This is 3 times 3 is 9. 8 times 1.5 is 12. 9 plus 12 is 21. That works there. Here I get 6 minus 3 times 8 is 12. 6 minus 12 equals negative 6. That works. So we can always check we can always substitute back in to check our answers. So for this one here, I'm looking at this and I say, well, I could either eliminate the y's by increasing this by a factor of 3. Or I can get rid of the x's by increasing this by a factor of 2. So again, I'm going to make sure I label my equations. I'm going to multiply equation 2. So I'm going to do 2 times equation 2, and that's going to give me 4x minus 18y plus 36 equals 0. Okay, so once I've made the coefficients equivalent, I'm going to subtract. So I'm going to subtract all that. So I'm going to do minus. 4x minus 4x is 0. 3y minus negative is 15y. 9 minus 36 is negative 45 equals 0. So 15y equals 45. Y equals 3. Okay, and then again, once I've solved for one variable, I can substitute back in. Okay, so in equation 2, I've substituted y equals 3, so it's going to be 9 times 3 plus 18 equals 0. When I've done that, I have now just a one variable situation again. So 2y minus 27 plus 18 equals 0. 2x minus 9 equals 0. Plus 9. Divide both sides by 2. So I end up with 9 over 2, or 4.5. Okay, and then we can always double check. X is 4.5, so I get 4 times 4.5 is going to be 18, minus 3 times 3, which is 9, so I end up with 9. 18 minus 9 equals 0. That works. Here I end up with 9 over 2 times 2 is 9, minus 9 times 3 is 27, so 9 minus 27 is negative 18, plus 18 equals 0. Okay, so it does work out. Okay, so we can check by substituting back and checking to see that it actually works. So here we have a system, a quadratic system now. So we can eliminate either the y or the x. However, when we look at this system here, I can match the coefficients on x squared, but that leaves me with an extra x here, which doesn't cancel with anything on this equation here. So we're gonna, even if we can get rid of x squared, we're gonna be still left with x's. However, if I take a look at this one here, the y's, there's just y and y. There's no y squareds in here. So this allows me to then get rid of the variable y much easier than getting rid of the variable x. Okay, so I'm going to label my equations 1 and 2. So I'm going to subtract equation 2. So it's going to be y equals negative 2x squared plus 1. So I'm going to take away that equation. 3x squared minus 2x. Y minus y is 0. 0 minus 2x squared is positive 2x squared. 0 minus 1 is negative 1. Okay, so what ends up happening is I do end up with a quadratic in terms of x, but I do know how to solve quadratic equations. So I'm going to subtract 2x squared from both sides. I'm going to add 1 to both sides. This one is easy enough to factor. Okay, so x equals 1. So I'm not done. Remember that I solved for x. I still need to solve for y. So I'm going to back substitute that into one of these equations. Now, since I have a choice, it looks like this one's much easier to substitute in. So I'm going to substitute into that equation there. Okay, so it doesn't matter which one we substitute into. I get y equals negative 2 times 1 squared plus 1. So y is equal to negative 1. So there's my solution for x and y. So if I plugged in x, I'm going to get negative 2 plus 1 is negative 1. X is 1 is 3 minus 2. That's positive 1. Y is negative 1. 1 minus 1 is 0. Okay, so it does work.